even and odd functions. So what are even and odd functions? A function f is said to be an even function if f of minus x is equal to f of x, and this is true for all x. It has to be true for all x. Similarly, a function is said to be odd function if f of minus x is equal to minus fx, and this is also true for all x. So a function will be odd function if f of minus x is equal to minus fx, and this is true for all x. Now, how will the graphs of even and odd function look? You see, this is the graph of an even function, and this will be symmetrical with respect to this y-axis. Why it has to be symmetrical? Because f of this x is same of f of this minus x. So x, and this fx is equal to minus f of minus x, so it has to be symmetrical with respect to y-axis. Now, how will the graph of an odd function look like? This is a graph of an odd function. You see, this is x, so f of x is minus f of this, f of minus x is equal to minus fx, so this will go down. So this is symmetric with respect to origin. Okay, so like you can say that whatever fx was here, it will be here but downward direction. So this graph, you can say, is symmetric with respect to origin. Now let's see. Now we'll draw graphs of some simple functions. So first of all, this is a family y is equal to mx plus b. Obviously all of you know that y is equal to mx plus b will be a graph. Its graph will be a straight line. What I am doing in this case, I am keeping my b fixed and varying m. That is varying m meaning I am varying the slope, but I am keeping this point b as fixed. So what will happen? This will be a family of straight lines whose slopes are changing. Like the slope of this one will be say 2, then this one will be 3, this will be 4. So the slopes are changing, but this point b where it is intersecting the y-axis, that is fixed. So this family is y is equal to mx plus b. Similarly, if I draw a family where y is equal to mx plus b, where m is fixed, that is slope is fixed but b is varying. So slope is fixed, so these are set of parallel lines, and for each line this b is changing. So this is a family where m is fixed and b is varying. Now another function is y is equal to x. This is very simple like this. Y is equal to x square will be a parabola like this, and you see this y is equal to x square is an even function, so this is symmetric with respect to y-axis. Y is equal to x cube will be like this, and you see this is an odd function, so it is symmetric with respect to origin. Y is equal to x power 4, again it is an even function, it will be like this, so it is symmetric with respect to y-axis. And y is equal to x to the power 5, it is an odd function and it is symmetric with respect to origin like this. Okay, now let's see. Let's see an exponential kind of function. Y is equal to b to the power x. If my b is greater than 1, then what will be? This curve will be like this and it will be rising curve. So this is for b greater than 1. If your b is lying between 0 and 1, then this curve will be falling curve, and both these curves will be meeting at this point 1. Why? Because for x is equal to 0, b to the power 0 will be n for what? Any b, as long as this b is not equal to 0. So for 0 less than b less than 1, this is a falling curve, and for b greater than 1, this is a rising curve like this. This is a falling curve. If I change my b, then what will happen? You see, b 2 to the power x is like this, 3 to the power x will be like this. So as my b is increasing, this curve is becoming more and more steeper. You see, this 2x was like this, 3x is like this, 10 to the power x is going like this. So this is becoming more and more steeper. Similarly, if this is half to the power x, so this is here 1 by 10 to the power x, so this is falling like this. So as this b is decreasing, this is going towards this direction. The half to the power x is like this, 1 by 3 to the power x is like this. This is all very simple, you can try it yourself. Now let's see another. You see, this I have shown the family y is equal to x to the power n when n is even. Now since n is even, this is an even function, so this will be symmetric with respect to y. This is y is equal to x square, y is equal to x to the power 4 is given by this yellow curve, y is equal to x to the power 6 is given by this green one. So for what is happening, for x greater than 1, x to the power 8 is greater than x to the power 6 is greater than x to the power 4 is greater than x square. That's why for x greater than 1, you see this violet color, that is x to the power 8, is steepest. It is lying ahead. This is lying above all the curves. Then we have the green curve, then you have yellow curve, then you have blue curve. But exactly opposite happen when you go in this region, x less than 1. For x less than 1, x square is maximum, then you have x to the power 4, then you have x to the power 6, and x to the power 8 is smallest for x less than 1. That's why for in this region, that is from 0 to 1, this violet color curve, that is of y is equal to x to the power 8, it is lying below all the curves. Okay, exactly similar property, same property will be followed in this case also, but only difference will be, since this is n is odd, so this is will be an odd function, so it will not be symmetric with respect to y-axis, it will be symmetric with respect to this origin. And you see what is happening, for x greater than 1, this my violet color, that is x to the power 7 is maximum, and for this region, that is 0 and x less than 1, that is between these two endpoints, this violet curve, that is x to the power 7, that will be smallest. Let's see another graph of a function. This time we have taken a trigonometrical function. Suppose this is my y is equal to sine x, this blue line. Now if I have to draw a graph of say y is equal to 2 sine 4x, first of all this modulus 2 has been increased, so this violet will be 2 times, the modulus will be here. Now what has happened, this sine 4x, so y is equal to a sine bx, a is the modulus or say amplitude, the period is 2 pi by b, or frequency will be mod b by 2 pi. So when this b has become 4, the frequency of this function has increased. That's why you see this violet curve, it is doing oscillation at a much faster rate. So this violet curve is 2 sine 4x and the blue curve is y is equal to sine x. This is a test to find out, suppose in some questions you are asked to find whether this function is one-to-one or not. So there is a test for finding one-to-one functions also, that is called horizontal line test. What this means is, suppose you have been given horizontal line test. Suppose you have been given graph of a function, say like y is equal to fx. You draw a horizontal line. If that horizontal line intersects the graph at only one point, then you can say this is a one-to-one function. What is the definition of a one-to-one function? One-to-one function means that if my fx1 is equal to fx2, this should imply that x1 is equal to x2. It means that each function, if x1 is not equal to x2, then fx1 will not be equal to fx2. And this is the same condition I have given in reverse order. Okay, so you see this horizontal line test, this line is cutting at say this point x1. So now this, since this line is not cutting at any other point on this graph, it means this is a one-to-one function, because x1, this fx1 is unique. Similarly for this x2, this fx2 is unique. Now you see this graph, this is a function because it is satisfying the vertical line test, so this is graph of a function. But this is not one-to-one function, because when I draw this horizontal line, this is touching at these 2 points. Now what is happening, that f of x1, that is this, is same as f of x2, and my x1 is not equal to x2, so this is not one-to-one. So based upon this geometric criteria, I can say that all increasing or decreasing function, meaning strictly increasing and strictly decreasing functions, they are one-to-one. Why? Because you see, if the function is strictly increasing, you draw a straight horizontal line, it will intersect at only one point. Similarly, for a decreasing function, you draw a horizontal line like this, it will intersect the curve or the graph at only one point. So these decreasing function, strictly decreasing and strictly increasing function are one-to-one function. Why I am telling strictly increasing? Because if you just make a function like this also which is increasing, then it is constant. Now this is not one-to-one. This was increasing till here. After this point it became constant. So this is not one-to-one. So when I am saying that a function has to be one-to-one, it means it has to be either strictly increasing or strictly decreasing in certain intervals. It cannot lie constant like this, or it cannot do oscillations like this function. So it has to be strictly increasing or strictly decreasing.